Hi, hello everyone. This is Pawan Kalyan. Today we are discussing about solve recurrence relation by generating functions and some graph definitions. My roll number is 64. The definition of generating function is let a0, a1, a2 and so on be a sequence of real numbers. The function g of x equal to a0 plus a1 plus x plus a2 x square plus and so on a power n x power n and so on. This is equal to the sigma n equal to 0 to infinity. A power n into x power n is called a generating function for the given sequence. It can be represented by g of x equal to sigma n equal to 0 to infinity a power n x power n. Some example is solve the reconciliation a power n minus 7 a power n minus 1 plus 10 a power n minus 2 equal to 0 for n greater than equal to 2. We know that the generating function formula is sigma n equal to 0 to infinity a power n x power n given a power n minus 1. This is the given equation. Here order is 2 because highest subscript minus lowest subscript. Here highest subscript is a power n minus 2 and a power n minus 1 is the lowest subscript. Then order is 2. Here sigma n equal to infinity, here apply sigma every term in the given equation. Then look like this g of x minus a0 minus a1x plus minus 7x of g of x minus a0 plus 10x square g of x. Here common g of x, then the equation look like this: 1 minus 7x plus 10x square equal to a0 plus a1x minus 7ax minus a0. Then divided in this term going to this side, then divided, then the equation look like this: a0 plus x a1 minus 7 a0 by 1 minus 7x plus 10x square. Then the equation becomes like factorization method. Then 1 minus 7x plus 10x square is then 1 minus 2x into 1 minus 5x. Then the equation becomes g of x equal to we know that the c1 by 1 minus 2x and plus c2 by 1 minus 5x. Then the c1 equation look like this: c1 sigma n equal to infinity 2 power n into x power n plus c2 sigma n equal to 0 to infinity 5 power n. Then a power n we required solution, so c1 2 power n plus c2 5 power n. Here a is 2 and here 5. Some graph definitions in this graph theory. The definition of a graph theory is the graph g of vertices comma edges consists of two components: vertices comma edges, where v is called the vertices and e is called the edges, such that each edge is identified with an ordered and unordered pair of vertices. Here we know that a null graph is said to be a null graph if g has no edge. Here when there is no edge in the graph, then it is called a null graph. And also a directed graph. A graph G is said to be a directed graph if all edges in G have a direction. That means G is said to be a directed graph if all the edges have a direction, then it is called a directed graph. Undirected graph means a graph G is said to be an undirected graph if no edge of G has direction. This is called an undirected graph. Order and size. The number of vertices in a graph G is called order of the graph, and the number of edges in G is called the size of the graph. This is the order and size of the finite and infinite graphs in the graph theory. The graph G of vertices comma edges is said to be a finite graph if the number of vertices and the number of edges in G are finite. Otherwise, it is as infinite graph. Here we consider two graphs. One is finite graph and another one is infinite graph. So number of vertices and the number of edges in the graph G are finite. Otherwise, it is a infinite graph in the graph theory.